Hey guys, I am the math professor Kyle Martin. In this video, we're going to continue our factoring playlist. This time we're going to factor our trinomials when our a term equals 1, all right? So in this video, we're going to learn when I can use this. We're going to give you 3 examples of factoring when a does equal 1. And then lastly, just remember that there are timestamps in the video player down below. That's the little bar that scrolls back and forth. If you click on it, try it right now, it'll take you to our examples, other parts, whatever you need, all right? So let's get into it. All right, so first off, when can I use this? When can I factor trinomials when a equals 1? What does that even mean? Well, first off, a trinomial is when there's 3 terms. We have, in this case, x squared is one term, 9x is another term, and 20 is the final term. How do we know those are terms? Terms are separated by addition and subtraction signs, okay? In this case, I have addition sign here and addition sign here. And so on each side of those, I have 1, 2, 3 terms, okay? That's a trinomial, just like a tricycle is a bicycle with 3 wheels, right? There's 3 of those wheels. This is a trinomial. There's 3 terms. And then the a equals 1. Well, our first term we're just going to call is a, b, and c. And so our first term a, we know this equals 1. What I mean by that is that the coefficient, or the number in front, is a 1. Typically, there will not be a number there. It'll just say like x squared or p squared or n squared. Whatever letter you're working with, it'll just be that letter squared. Okay, and so that's when we know we can use this method of factoring. Right, so to help us out with this first one, remember my first, second, and third terms, these are a, b, and c. It's important to remember that just in the correct order. If they're ever not in the correct order, it should go x squared, 1x, no x, okay? So like 2, 1, none in terms of decreasing order for your x's, all right? Now, when we have this, a little trick that I like to use is this graphic organizer over here. It's just a simple X shape, right? And on top, I'm gonna take my a term times my c term. So remember, this was a 1, right? A equals 1. 1 times 20 is 20. We're gonna do a times c in there, okay? In the bottom, I'm gonna put my b term. In this case, it's 9. And then what I need to do is on the sides, so these spaces over here, I need to find 2 numbers that, I put a dot here to mean multiply, 2 numbers that multiply to be 20, and those same 2 numbers have to add to be 9, the b term, okay? So to figure that out, sometimes that can be a little tricky. To help us figure it out, I can take this top number 20 and write out factors of it, okay? Meaning what numbers can be multiplied into 20 to get 20. So 1 times 20 is 20. 2 times 10 is 20. 3 doesn't work, right? You can't take 20 divided by 3 evenly. 4 though, 4 works. 20 divided by 4, I should say, is 5. And then you'll notice I would wrap back around, and so I don't have to go any farther, okay? So I'm looking for one of these pairs that either adds or subtracts to be 9. And I see right away that 4 and 5 do that. So the outside parts here are going to be 4 and 5. And let's just double check it. Does 4 times 5 equal 20? Yes. And does 4 plus 5 equal 9? Yes. Yes, it does. Okay, so then the answer, we're going to go back to our problem over here. And the answer, I can take and split this x squared to be x and x. When I multiply those back through, x times x gives me back to x squared. And then I'm going to put the 4 on one side and the 5 on the other. Those are just the 2 numbers that I found here. Okay. Now, these were both positive, so I'm going to put x plus 4 and x plus 5. And if you were to multiply this back together, if you were to FOIL this or distribute those back together, you would end up with this part in red up here, x squared plus 9x plus 20. Let's try another one. All right, example 2 says x squared minus 2x minus 8. So again, I'm going to use my graphic organizer and take my a term times my c term. 1 times negative 8 is a negative 8. And then my b term just gets plopped down here with negative 2. Okay, so I'm going to take my a times c. It does not matter if this is positive or negative. We're just going to take the positive version, which is 8. And I'm going to try to write out factors of that. So 1 times 8 is 8. And the only other thing that works here is 2 times 4. So are there any of these pairs, again, 1 and 8 or 2 and 4, that either add or subtract to be negative 2? Yeah, 2 and 4 would work, okay? 2 and 4 would work. In order to get a negative down here, when I add those together, I need my bigger one, in this case 4, to be negative. Okay, so now 2 times negative 4 is a negative 8, and 2 plus negative 4 is a negative 2. So now when I write my answer over here, put your two sets of parentheses, x squared is getting split to be x and x. Then you're going a positive 2 and a negative 4, and that is your answer. All right, last example, number 3 says x squared plus 8x plus 15. Again, your a times your c. You should be pros with this by now. 1 times 15 is 15. Put that in your graphic organizer. Your 8 is going to go down here. Two numbers that multiply to be 15 and add to be 8. Let's try to do this in our head. Well, what multiplies to be 15? 1 and 15. 3 and 5. Yeah, I think that would work, right? 3 and 5. 3 times 5 is 15. 3 plus 5 is 8. So right there we have our answer, x plus 3, x plus 5. Again, the x squared is being split to x and x. The 3 and 5 come from right there, being x plus 3 times the quantity x plus 5.